Alright, so right here we have the Altera FPGA board. I've programmed it with a simple processor which only implements a few basic instructions, namely jump, add, move, and load. But it's enough for this particular program, which is actually going to be the Fibonacci sequence. So what you're going to see here is you're going to see the sequence being generated 1, 1, 2, 1, 2, 3, and so on, and then 5, 8, so on. So let's actually see that in action. So you load them 0, 1, 0, 1, and you get 0, 2. You add them together, you add these two together, you get 3. You add these two together, you get 5. You add these two together, you get 8. You add these two together, you get 11, and so on. So what we have here is the Fibonacci sequence, and you'll notice this one in particular is called the instruction pointer. So what we do is we have a series of instructions. We have 4 different instructions, which are, let's look right here. There are 4 different instructions. They are add, move, and then jump. So this is basically how the Fibonacci sequence works. You add together. Let's actually look at the C program first. So what you do is you take your seed values A and B, you add them together, and you store it into your output value, and then you just shift them over by one, and then you repeat the process recursively. And what you get is the Fibonacci sequence. And let's actually look right at the Rtl Viewer for this entire processor. So what we have here up here is gigantic thing is the CPU, and what we have here is on the right side is the display units. So if you zoom right into the right in here, what we get is the CPU outputs 3 different relevant values, which are register stack 0, 1, and 2. Now these are the ones we display right on here. So this is register stack 2, this is 1, and this is 0. Okay, so let's zoom out again, and let's go right into the CPU. So first thing you'll notice is this is a gigantic mess, and the reason for this is because the VHDL program actually generates a lot of synthesizer actually generates a lot of these little multiplexers. Now you might be wondering what these are used for, and they're actually used right here in, you'll see the highlighted lines of code are all the ones that generate all this gigantic mess right there. This gigantic mess is generated just by those 5 lines of code. These lines of code, they're for indexing an array. Now the thing is, VHDL can't really do that because we're working at the hardware level, and there's the only way to do that is by using little tricks with multiplexers, and as you can see, these little tricks actually generate a whole ton of multiplexers. And let's move on. Let's see right here. Let's actually look right at the instruction stack. So this is what we use in this is what we feed into our CPU. Instruction line by line, and each instruction, the first instruction starts from 0, goes upwards, and then you get third instruction for so on, or sorry, 0th instruction rather. First instruction, second instruction, third, fourth. And we are only using every alternating one, but that's fine. We basically just skip over this line. So let's look at the first one. It's just doing nothing, zeros everywhere. So in the second instruction, we load from 0, 1. What is 0, 1? 0, 1 means 0, 1 means the particular register on the board. So this is the first 0, 1 register, and into that we load the value of 1. So into the first register we load from the memory location 0, 1. Now in our memory we've defined 0, 1 to be just the value 1, so we're good there. We load the value 1 into there, and you can see right here instruction number 2. We've loaded the instruction number 2. We've loaded the value 1 into our register. Okay, so let's move on to the next instruction, which is load into our second register the value from the memory unit 2. So in that case, the value is 1. And so let's run it right here. Let's step through it. Instruction 4, we've loaded the value 1 into register 2. Okay, and then let's move on to the third, or rather 6, I guess. What we're doing is we're adding together 1 and 2, those registers. So we add together these two registers and we put it into the 0th register. Let's see what happens. So we've added these two together. This is our 6th instruction. We've added these two together to form 2. Right there. And then we basically apply a move command, and what it does is it moves the value from register 1 into register 2. And let's see that. Well, in this case, it would look like nothing happened. Let's skip over a few more. Let's go to right to next iteration. All right, so this was number 8, yes. So what we've done is we've shifted this value into there. Now we also want to copy this value into there, which is the next instruction, instruction 0A. So right there, we do that. And finally, actually, there was one more step in between, if you noticed. We actually jump right back. So what this line does is we jump right back to number 6. And we start from here again. And from here, we can do the addition and then shifting variable registers and repeat right back to there and so on. All right, so one last thing is that we've actually defined, now obviously the processor can't understand what load means, or it doesn't know what the string means, so you have to represent it in number format. So I've chosen the value 1 1 to represent load, and you can see it right there. And we've also used the value 0 1 here, 0 1 right there, and another 0 1 goes right there. So basically it's really very ordered. And we can actually take a look at our instruction set right here. So we have, these are our instructions, 0 1 0 0, which is do nothing, 0 1, which means jump, 1 0 means to move between, so move means copy the value of A into C. And then you have 1 1, which means load from memory. You load into C from the memory location A. And 2 0 is just addition. So right here we have, for example, our addition statement, which is 2 0 add. And then we let 0 0, the value in the 0th register, be equal to the value in the first and the second register added together. So the sum of these two, this one and that one. So you can see they correspond to A, B, C, and our instruction, IN. And, or INSTR if you prefer. And let's actually see our entire thing in action one more time. Right, starting from zeros, let's flip the switch. And there you have it, folks, the Fibonacci sequence, all on a processor created in VHDL.